Hello, and good day. Today's topic will be talking about ketones and aldehydes, mainly on naming these two functional groups. Now, in organic chemistry, there are a lot of functional groups, and going over all of them and how to name them in one video would be far too difficult. So today we'll be focusing on just the ketones and the aldehydes. So let's get started. So a small overview. Aldehydes and ketones are organic compounds that incorporate a carbonyl group. Now, if you need to know what that is, check this out. It's this one, C double bond O. So a carbon atom of this group has two remaining bonds, as you know, that may be occupied by a hydrogen, an aryl, or an alkyl substituent. So if at least one of these substituents is a hydrogen, then the compound identifies as an aldehyde. If none of them are hydrogen, then the compound is known to be a ketone. So to make it easier, an aldehyde contains a carbonyl group bonded to at least one hydrogen atom, while a ketone may be bonded to two sets or a variety of carbon-containing substituents. So take a look here. This is how a carbonyl group would initially look like. Now this is an aldehyde. One is a hydrogen, as you can see, and this is a ketone. R and R, where R can be a variety of carbon-containing substituents, as mentioned a while ago. So next, some stuff you need to know. So I'm not really going to go over this very much, but if you're taking notes, do take notes here. Take a picture if you want. So group A, it's a functional group. So these are functional groups indicated by prefix or suffixes. So we got carboxylic acid functional group, and aldehydes, ketones, alcohols, and amines. And there are actually some other stuff to know. So you can see that we'll focus on aldehydes and ketones. If they're in priority, they'll be using the suffixes, meaning if they're the ones being focused on, if they are the main. The suffix for aldehyde is al, and for ketones it's on, but the prefix is oxo for both of them. Now, do take note of these other ones, such as the alcohol and amines. Know their prefixes, because later we'll see them as substituents of things we'll be adding to, ketones and aldehydes. Next is other functional groups. These are the alkanes and alkenes. And, rather the ones shown here are the alkenes and the alkynes, being the double bond and the triple bond. And here are other substituents, alkyls, alkoxy, halogens. Do note these. The fluoro, chloro, and bromo and iodo having a fluorine, chlorine, bromine, and iodine substituents. And here's other substituents. So NO2 is nitro, this is vinyl, allyl, and this is a phenyl substituent. And do note that benzyl looks exactly like phenyl, except it has this carbon and two hydrogen here. Alright, so let's go next. So other stuff to know. So common alkyl groups. So yeah, like I said, let's say methyl, you would replace, it'll be methane. So you replace the methane with eel. So it'll be methyl, ethyl, propyl. Then here's some other stuff to know, because these are specific shapes. This is a propyl, but it's shaped like this instead of this. So it's isopropyl. This is butyl, shaped like this, sec-butyl. And more over here. So do know these, because we'll be seeing these much later. So, do take note of this also. Maybe it'll be useful for you. So first, let's go on with naming aldehydes. So the IUPAC rules, in the IUPAC rules, aldehydes are named with the suffix al. And things to remember, aldehydes are always given the number 1 location position in the numbering. So when you start counting, aldehydes are always prioritized to be counted as number 1. And the number is not needed in the name because, of course, aldehydes are number 1. And aldehyde carbonyl groups must always lie at the end of the carbon chain. So they cannot be in between. They have to be in the edges, in the end. So for example, let's look at this. Please do identify the aldehyde group here. So you have here, let's make it easier. This is the aldehyde group. As you can see, with a hydrogen. So what's the parent chain here? You have 1, 2, 3, 4, 1, 2, 3, 4. Yep. So we have ourselves. This is butane, right? But we have an aldehyde. So how do we say that? We say that as butanol. Alright, seems straightforward, right? Butane, butanol, because it's an aldehyde, ends with the suffix al. How about this one? Similar thing. Count the carbons. We know that this one is a 1, 2, 3, 4, 5, 6 hexane. And an aldehyde attached to it, it would be hexanol. Very straightforward. Now let's go to a little bit more complicated examples. How about this one? So as you can see, we have another substituent here, being a methane substituent. This is 1, 2, 3, 4, 5. 5. So it's a pentane, pentanol. But we have a substituent at this branch. But remember, we can't count this as number 2 because we have to start counting from the aldehyde. 1, 2, 3, 4. So this is a 4-methyl pentanol because the methyl substituent lies on the 4th carbon. Alright, how about this one? So we have our aldehyde here. We start counting here. 1, 2, 3, 4. 1, 2, 3, 4, 5. This is another pentane, pentanol. But we have a chlorine substituent. What would that be called? Since it's in the number 2, we would call that a 2-chloropentanol. Alright, getting easier, aren't we? Getting easier now. How about this one? Do forgive my dirty drawing, but yeah, we've got a double bond here. What would we call that? So again, 1, 2, 3, 4, 5. This is a pentane. With a double bond, it's a pentene. But we have to count where the double bond is. So it's a pentenol. It's a pentenol. Essentially, it's a pentene with an aldehyde. Pentenol. But we have to know that the double bond is there. So it's in the 3rd carbon, 3-pentenol. Because it lies on the 3rd carbon here. Now, how about this one? This one, 1, 2, 3, 4, 5, 6, 7, 8. It's an octane. Aldehydes here, so we start counting here rather. 1, 2, 3, 4, 5, 6. So it's octanol. But we have 2 substituents. An amino group and an alcohol group. Now remember what the prefixes of the amino and alcohol groups were. So for amine, it's amino. And for alcohol, it's hydroxy. So let's put that all together. Counting, this is the 1, 2, 3rd, 4, 5, 6, 3rd and 6. We mentioned the amine first because we need to know about alphabetical orders. So A comes before H, so it has to be mentioned first. 6 amino, 3 hydroxy, octanol. Alright? So do know that the numbers don't determine the order and how you write the name, but the alphabetical orders do. Don't worry, I know it's overwhelming, but later on as we continue, you will see what I mean. More examples will really bring this to be easier. Now how about this one? A little bit more complicated. First, let's count the parent chain. This time, let's start here so we don't get confused. 1, 2, 3, 4, 5, 6. That's 6, so it's a hexane with a aldehyde, so hexanol. We have 2 substituents on the 2nd, 3rd, and 4th. So what's the difference between these 2? Remember? Remember the difference between a phenyl and a benzyl group. The benzyl has an additional carbon, which is exactly what this is. So this is a benzyl and this is a phenyl. How we write that? 2-benzyl, 4-phenyl, hexanol. Now, know that we mentioned the benzyl first because, of course, B comes before P. So it's a 2-benzyl, 4-phenyl, hexanol. Next up, another special case. Now, what if the chain cannot include the carbon of the CHO? So it's really, the carbon is separate from the chain, unlike these ones where this carbon is part of the chain. What if it can't do that? So we just use the suffix carbaldehyde. Yep, so like a little trick. So the carbon isn't part, the carbon is out. So just add a carbon in the aldehyde, carbaldehyde. A little trick that I use myself. So this is a cyclohexane, carbaldehyde. Alright, cyclohexane carbaldehyde. Because the carbon is not part of the chain. It's just branching out as seen. So some special cases, another special cases, what if it's a benzene attached directly to an aldehyde? So like this one, it's like this, except it's a benzene, specifically a benzene ring. So we would call that benzaldehyde. So this is only for this case, something that looks like this, we would call it benzaldehyde. A benzene directly connected to an aldehyde group. So what about this? What would you call this? So pause the video if you want and analyze it. So we have cyclohexane here attached to a aldehyde. So we would call this cyclohexane carbaldehyde. But we have a substituent here, a methyl substituent. So remember, we start counting here, 1, 2. So this would be 2-methyl cyclohexane carbaldehyde. Next, how about this one? It's a cyclopentane carbaldehyde with a substituent OH in the 1/2/3. So we'd call that 3-hydroxy cyclopentane carbaldehyde because the alcohol group is on the 3rd carbon. Counting starting from here. How about this one? This one looks complicated, but it actually isn't really complicated. You just need to know the rules that we mentioned a while ago. So this is a benzene ring directly attached to an aldehyde. So that will be a benzaldehyde, right? And now let's begin counting. 1, 2, 3, 4. Now you might ask, why didn't we start counting like this? 1, 2, 3, 4. It would still be the 4th one on the chlorine, right? Or, yeah, either way. But the problem is, if we start counting here, it'll be 1, 2, 3, 4. This is 2, 3, 4. If we do it like this, 1, 2, 3, 4, 5, 6. We need to make sure that the numbering uses smaller numbers as possible. It'll be easier to understand that way. It'll be easier to interpret it, and it'll be easier to reverse the process. So, okay, let's do this first. This is a benzaldehyde with a chlorine, a fluorine, and a methyl. So we do letter C first. 4 chloro, 3 fluoro, 2 methyl, benzaldehyde. Again, I said we didn't start counting here because we want to keep it 4, 3, 2. If we count from here, it'll be 4, 5, 6, which will just make it more complicated. So imagine if you were the person. Imagine if this was given to you and you had to draw it, and they'd say 6, 4, 5, 6. The bigger the number, it would be harder for you to interpret and imagine it. So better stick with smaller numbers so we can easily interpret it, easily write it, and draw it down. And that's also a rule that you should use the smaller numbers. But we also use the rule of alphabetical order where the chlorine went first. You can use 4, 3, 2. These don't determine the order of the name, but rather the alphabetical order of the substituents do. Alright, so yeah, don't get me wrong, this is really a lot to take in, probably, but you'll get used to it. So just look at this example, go over it if you need to, and it really defines the orders that we have to use. Next, we'll bounce into naming the ketones. So in the IUPAC system, ketones are named with the suffix "-one". Things to remember, the number is needed this time. And the ketone carbonyl function may be located anywhere within the chain or ring. This is why, unlike the aldehyde, where we don't have to put the number, the ketone we do have to put the number because it can be placed anywhere in the function chain. Rather, it can be placed anywhere in the chain or ring, this carbonyl function group. So let's take this one. This is actually the easiest example of a ketone. This is propane. Propanone rather. It's a propane with a ketone, propanone. Now I just mentioned a while ago, but you just said you need to put the number. Why isn't there a number here? Why isn't there an indicated number? Well, that's another thing. I use this example to explain the rule. If the ketone is placed in the only possible location it can be placed in the whole group, then and only then you don't need to say the number. So this, if you place this double bond O here, that will not be a ketone. If you place it here, it won't be. The only possible place in this exact chain is in here, and that is known as propanone, more commonly known as acetone. But yeah, the reason we didn't put the number is because it cannot be placed anywhere else. That's the only possible position. So it's understood to be like that. Alright? It's understood to be like that, and I hope you got that. Next up, how about this one? Now this one, it can have other possible locations. You can put it here or here. So it's in the center. So how would you count this? So we got ourselves a 1, 2, 3, 4, 5 pentane. It's a pentanone, right? But let's count which one is it on. If you count from the right, it's in the third. If you count from the left, it's in the third. So either way, 3 pentanone. Alright, pretty straightforward, right? I would say this might be actually easier than the aldehyde. Next up, how about this one? So our ketone group is here. Alright, so ketones have higher priority than the bromine substituents, so you start counting here. 1, 2, 3, 4, 5, 6, 7. It's a heptanone. So the bromine is on the 7th. So 7 bromo, 2 heptanone. This time we mentioned 2. Second one, heptanone. Bromine on the 7th. 7 bromo, 2 heptanone. Pretty easy. How about this one? 1, 2, 3, 4. Alright, so we have a methyl group on the third one and a ketone here. You'd call this 3-methyl 2-butanone. Yep, that's that. How about this one? There's a double bond. What would you call this? So take some time, pause the video, analyze it. Ketone lies on the second one, so it's going to be a 2 something. Alright, the double bond lies on the pentene. On the fourth one rather. Now if this was an aldehyde, we would just say 4-pentenal. But this is a ketone and we have to identify the number. So it's 4-pentene-2-one because the ketone is on the second one. So this is only in the case for like double bonds and triple bonds where you have to identify it initially, then put the number of the ketone in the middle before the suffix. So another example, how about this one? So we got ourselves a cyclopentane, right? So this one is basically a cyclopentanone because you can put just this alone, you can put the ketone anywhere in the in this ring, and it would still, that's where it would start counting. So this is actually another exception. Look, I lied to you. That other one was not the only exception of not putting a number. My apologies. This one is also another exception. If it's a ring, if it's a cyclopentane, cyclohexane, whatever, and just a ketone, then you can put the ketone anywhere else, anywhere in this ring, and it wouldn't matter where the number was because you can rotate this ring anywhere, and as long as there's nothing else bothering it, then that's that. It's just a cyclopentanone. This one, on the other hand, you can't just straight up call this a cyclohexanone. There's a methyl group. So you start counting here. 1, 2. Now since this is the first one, you don't need to mention it again. If it's 1, you don't need to put 1. It's just 2-methyl cyclohexanone. So the methyl is on the second one. You don't need to put a 1 on the hexanone because, like, it's understood already. How about this? So we got a pentanone, cyclopentane, cyclopentanone. We got a bromine and a chlorine. B comes before C. So 1, 2, 3, 4. Well, what if we count like this? Okay, wait, hold on. So basically this is the answer. 3 bromo, 4 chloro, cyclopentanone. We start counting at the ketone. Now, why did we start counting here? 1, 2, 3, 4. When we could have started counting here. 1, 2, 3, 4. Now here's another thing to note. Right, we know that it's arranged in alphabetical order. Yeah, what if we just say 1, 2, 3, 4 bromo, 3 chloro? Well, it would look better, and it is better, that you gave the smaller numbers to the one going first. In situations like this, where either way the cycle would be the same, if it's like this, then really choose the one that comes first alphabetically to be given priority in counting. I know, so many rules, right? But it's alright, don't worry. There's a lot of rules, but you'll get there. So yeah, 3-bromo, 4-chloro. Because either way, it will be the same. Now, how about the priorities in naming? So please do look at this table. Take a picture of it, take notes, do what you need to do because it's very useful. Now, as you know, these are the priorities. If they are on the top priority, then they end with the suffix. If they are not on the priority, then they start with oxo. Then you use the prefix. As you know, a while ago, there was an alcohol group on our aldehyde and our ketone. We didn't say oxo and all. Instead, since it's higher priority, we used the prefix of the alcohol, hydroxy, and ended it with the suffix of the higher priority, which is the aldehyde, or ketone, which is al and on. Do know that aldehydes are higher than ketones, and these all are higher than aldehydes and ketones. Especially the big boss up here, which is the carboxylic acid. If you see an aldehyde and a carboxylic acid together, then do know that the aldehyde has to surrender the suffix title and give its prefix to the carboxylic acid. So do take note of this. I'll go back to this as we proceed. So what about this? We have a ketone and an aldehyde. Who has the higher priority? According to the box, according to the table, the aldehyde beats the ketone. So we start counting from the aldehyde, and we use the suffix of the aldehyde. So it's 1, 2, 3, 4, 5, 6. It's a hexanal. And we have a ketone. So this is on the 5th carbon, so we have a 5-oxo hexanal, because oxo is the prefix of a ketone. It surrendered its suffix title to the aldehyde. So yeah, 5-oxo hexanal. What about this? So this is a carboxylic acid, and this is an aldehyde. Both of them are on the end of the chain. But who is stronger? Who is going to dominate this fight? So basically, the one that's going to dominate here is going to be the carboxylic acid, as you saw here. The carboxylic acid is on the top of the chain. He beats the aldehyde. And that being said, the aldehyde will surrender its suffix title and give its prefix title to the carboxylic acid. And do know we have a fluorine substituent here as well. So we start counting here. 1, 2, 3, 4, 5, 6. Fluorine is F, it goes first. So it'll be 5-fluoro, 6-oxo, hexanoic acid. Because oic acid is the suffix of a carboxylic acid. Now, I'm sure carboxylic acids are not it's not the scope of my report right now, but it's good to know because it's common, and we need to know that, because what if an aldehyde is mixed with a carboxylic acid? We need to know which to be given priority, and in this case the carboxylic acid wins. So it's 5-fluoro, 6-oxo hexanoic acid, hexane with a carboxylic acid. Alright, let's move on to one of the last things, which will be naming dialdehydes and diketones. What does this mean? What if we have 2 aldehydes and 2 ketones in a chain? So for dialdehydes, the location for both carbonyls are omitted because aldehyde function groups are expected to occupy the ends of the chain. Meaning, if we have 2 aldehydes, they are expected to be on the left and right end of the chain. And yeah, you don't need to put the number because of that. And it ends with dial. For ketones, on the other hand, they can be anywhere in the chain, and you do need to put the number. They can be in anywhere, and you do need to put the number. Therefore, yeah, you put the number, and the suffix ending is dione. So here are just some examples. So we have pentane dial. This is a pentane with 2 aldehydes in the end. Pentane dial. This one also, butane diol. Ketones, on the other hand, this one's on the 2 and 4. You count from the right, 2 and 4, from the left, 2 and 4. 2 and 4, pentane dione. Now, how about this one? This one is equal, so we can count from left and right. This one, on the other hand, we start counting really where more of them use up the lesser numbers. We can start here. 1, 2, 3, 4, 5, but 1, 2, 3 is 2 and 3 is better than 4 and 5. It's a hexane, 2, 3. 2,3 hexane dione. So this last part is pretty straightforward, but yeah, you'll see this. Best to know what it is, and let's see, what else do we have? Oh, that's actually the end of the report. So please do go over all this. Yeah, I'll probably link the PowerPoint down below for you guys to access. And yeah, do familiarize and really know this table of priorities because it's important. Moreover, you should really know these other stuff, the functional groups, these substituents, the difference between a benzyl and a phenyl, what else, and these two. You'll see more examples where they'll be branching out substituents with more names like this. So if it looks, this is a propyl, and this is a propyl, but it's arranged like this, so it's an isopropyl. This is a butyl, and this is a butyl, and this is a butyl. But if it's arranged like this, just butyl. If it's arranged like this, isobutyl. And if it's arranged like this, sec-butyl. Oh, this is also a butyl. If it's arranged like this is a tert butyl. It's just something to know. So I hope that helped. I hope you learned a lot from naming aldehydes and ketones. And yeah, have a nice day. Do leave a comment if you have any questions. And I suggest you practice with more problems, more questions for you to master this topic. Really, just reading over this table won't get you to memorize it that easily, but when you use this table and answer problems, then you'll memorize them easily. If you used all this while answering problems, then you'll memorize them easily. So really get to use time to memorize, use time to practice, and use time to yeah, read it to yourself, teach it. I'm actually reporting now because teaching it helps embed information in your brain. So hope this helps. Have a good day, and thank you for listening.